Problem solving is key, not only in mathematics, but in life. Whenever you come across problems, you want to make sure that you are really understanding what those problems are and that you're solving them in a logical manner. So this video is just to put us on the same page with how to break problems down. The first step is just read the problem carefully, and that is the key step there. Read it carefully and understand what that problem is asking you. Break it down. What is unknown in that problem? Let X represent one of the unknown quantities. And then what other things are they asking you? What other things are unknown? You can write an expression using that X for the other things that are unknown. If possible, try to draw a diagram of the situation, of the problem. All right, so those first steps kind of go together with just understanding what the problem is and breaking it down into variables and making an expression to represent the problem. Then after you've done that, you want to write an equation to model the conditions of the problem. So using those variables that you defined and the expressions, you're going to write an equation. Then you're going to solve the equation, and the last step is to check the solution that you got back in the original wording of the problem. So let's look at an example of that. Okay, this first example is talking about telephone plans, and I see some numbers right off the bat. But before I start doing anything else with those numbers, let's take a second to, first step, read the question carefully and understand what they're asking us. Choose a long-distance telephone plan. Plan A is a monthly fee of $20 and 5 cents per minute. Plan B has a monthly fee of $5, so much less, and only 10 cents per minute. For how many minutes will the cost of the plans be the same? For how many minutes will the cost be the same? So now the next step is to define my variables. Since they're asking me how many minutes will be the same, let's let X be the number of minutes. Okay, so now the second step is for me to write an expression that describes the other situations in the problem. So I'm going to have an expression here for plan A. It's going to have $20, and then I need 0.5 cents per minute. Okay, per minute, that's going to be like times each minute. And each minute I had just decided is going to be X. So I'm going to have 0.5X, and I'm going to have to add $20 to that. So A is 20 plus 0.5X. All right, and what about for B? Plan B is a monthly fee of $5 and 10 cents per minute. So the next step is for me to write an equation that will kind of combine these two together. They're asking me for how many minutes will the cost of the plans be the same. All right, they're asking me when the plans are the same. If they're going to be the same, then that means that plan A needs to equal plan B. So for my equation, let's put the two plans equal to each other. Okay, so now I have the plan for A equals the plan for B. So now, step 4 is I'm going to solve the equation. So now I'm going to solve it. Let's get our x's together by subtracting 0.5x to the other side. 0.10x minus 0.5 gives us 0.5 again for 0.5x. All right, and now let's move the 5 to the other side by subtracting. That gives us 15 equals 0.5x. And last step, divide by 0.5. Okay, so it looks like I got 300 equals x. So I have decided that it takes 300, that at 300 minutes the plans are going to be equal. The last step is for me to plug that 300 back in to see whether or not it's actually the solution. So if I have 300 minutes, how much will plan A cost me? Well, plan A is going to cost $20 and a fee of 5 cents times 300 minutes. So plan A costs $35. Plan B costs $5 and 10 cents for each 300 minute. Entering that also gives me $35. So it checked out, both plans are equal at 300 minutes. So my answer is that at 300 minutes, both plans cost $35. So notice the steps that we went through to solve the problem. So here's example number 2. I look at it and automatically I start seeing numbers, 50,000. I see 2 percentages here. But before I start doing anything else, let's take time to read the problem carefully and see what they're asking. Grandma is investing $50,000. Part is invested in non-insured bonds at 15% annual interest. The rest will go into government-insured certificate at 7% interest. She needs to have $6,000 in extra income from investments. How much should she put in each? Okay, so how much money should she put in each of the 2 investments so that at the end she has exactly $6,000 in extra income? So we're going to need to let one of these investments, one of these amounts that she puts in, be X. So since it says that part is in the non-insured bonds, and that happens to come first, let's let the part of the money that's in the non-insured bonds be X. So step number 2, we need to write an expression to represent the other variables in the equation. So the part that's in the non-insured bonds is X, and we know she has a total of $50,000 total to invest. So if I take the total amount and I subtract off the amount that she has in bonds, all of the rest of the money must be in the government certificate. Then what is left is in the government certificate. That's going to be the total $50,000 minus the X. Let's see if we can use those 2 things to write an equation that will give us $6,000 left in interest after her investments. So we know that the X, the non-insured, is at 15%. Let's change that percent into a decimal and multiply it by X. The money that was left for the government is this. So this is the amount that's invested at 7%. Okay, so here's my non-insured and my insured, and now that should equal 6,000. All right, so now we're to step number 4. Let's go ahead and solve for X. First, distribute. Combine like terms. Move the 3,500 to the other side and divide by 0.08. Okay, so it looks like we have 31,250 for our value of X. Now, if that much money is invested in the non-insured bonds, then how much money would be left to put into the government certificate? Let's subtract off. Leaves us 18,750 to invest in the government certificate. So we've got some answers. Let's go to step 5 here and plug them back into the original wording of the problem to see whether or not using those amounts of money will actually give us $6,000. Looks like the interest that she earns is here. Adding those together gives us exactly 6,000. All right, but in retrospect, I would suggest that Grandma maximize her profit instead of just aiming for a certain amount. Wouldn't you?